is IoT Quotient in India. Started in 2014, IoT Forum is now a vibrant community of over 2,500 plus IoT and deep tech startups developing technologies and solutions across the entire IoT stack from sensor to the cloud. Several thousands of active participants with 14 workforces and 100 plus volunteers. I'm Kiran Drappa here, one of the volunteer of TIE and also part of the leadership team of special interest group Edge AI. And also I'm a founder of I2G Global, a platform for co-founding high-value business ideas and turning them into reality. Our major focus is on the agri-food edge AI-based surveillance for critical installations and building technology-centric team-based industrial parks. To know more about IoT Forum, how you can contribute, how can you volunteer, please visit our website www.new.iotforindia.org, and also you can join our Telegram channel t.me/IoT4India. Okay, so coming to the today's session, it's a very special session. One of the rare occasions where we have industry leaders coming together to share their problems and inviting the startups to help them to solve them. It's really a huge value for each one of us here. And when that industry happens to be Indian Railways, the world's #1 passenger kilometers of 1,28,269 track kilometers. So we are fortunate to have a senior leaders from South Western Railway who are going to share challenges of their business. So I would like to welcome the senior officers who are attending on this call now and who are going to share their experience and share 11 problem statements. So we have Sri Sanjeev Kishore, General Manager, South Western Railway, Sri Milind Dioskar, Senior DGM, Sri PV Rajashekar, Principal Chief Signal and Telecom Engineer, Sri Neeraj Agrawal, Chief Project Director, Station Development, Sri Subbarao, Principal Chief Mechanical Engineer, Sri Sanjay Kumar, Chief Electrical Engineer and Locomotives, and Sri Shyam Singh, Divisional Railway Manager, Bangalore. South Western Railway was created by amalgamating the reorganized Hubli division from the South Central Railway and Bangalore and Mysore divisions from Southern Railway. It has been operational from 1st April 2003, having headquarters at Hubli in Karnataka, and this railway comprises of 3 divisions, Hubli, Bangalore and Mysore, and primarily caters to the Karnataka with 84% of its jurisdiction located here. The balance 16% of its route length falls in Andhra, Tamil Nadu, Maharashtra and Goa. Bangalore division of this zone is passenger oriented, while Hubli and Mysore divisions are freight oriented. Okay, the way the today's session is organized is an address by the General Manager Sri Sanjeev Kishore and brief introduction to the policy by Sri Milind, Senior DGM, and a briefing of challenges from engineering, mechanical and signal division, and question and after each of the division briefing, and at the end question and answer at the end of the briefing of all the challenges, and the session will end by 12:30 p.m. Now, I request Sri Milind, Senior DGM, to lead the session from now, with a request to General Manager Sri Sanjeev Kishore to briefly address the participants.
Hello, good morning, everybody. Thank you very much for a very nice and comprehensive introduction. I'm very happy to be here today, and I'm so glad that I can see there are over 77 participants now. Just to give you a brief glimpse of the history of what is happening in the railways. Over the last 4 decades, I've been associated with Indian Railways in various capacities. And this is the first time that we are experimenting, so to say, with the open innovation model. We have been working with the industry, as we call them, in different departments, basically different disciplines, primarily related to operations and various aspects of railway engineering. And we have been working on setting up of new factories, new plants, purchasing technology from all over the world, assimilating it, adapting it to suit our requirements, and so on and so forth. We also have an R&D wing called RDSO in Lucknow, and that wing has been interacting along with our major manufacturing plants, which are distributed all over the country. And we have been trying to upgrade our technology in all forms of processes, so to say. It can take various shapes and forms. For example, when there were difficult times in Punjab in late 80s, Indian Railways moved in to set up a rail coach factory in Kapurthala, and also in that process helped a very robust supply chain come up around that plant in north of Punjab. Similarly, there are many other case studies. In that series, what is happening now is that we have launched an innovation portal, and we have invited the startups, the small companies that are very agile and very innovative, and which can think and implement out-of-box solutions to come and help us improve the technology development scenario, the product development scenario, in a very novel way. To begin with, I would like to underline a few features of this new scheme. So at the bottom of the scheme is the fact that it is highly centralized at the moment. You must realize that that will cut a lot of bureaucratic delays. So you can directly upload your solutions and your proposals into a portal, which will then directly go to what is called a Committee of Executive Directors in Railway Board, which is Ministry of Railways in Delhi. Having worked as Executive Director Development, I can assure you that this committee will be working in a very efficient manner, and they will select the proposals which are fit for taking further in a gate stage kind of an approach. And it is not that only one proposal will be selected for one problem definition. There can be instances where more than one proposals are selected to be taken forward by the committee, and that will depend on the kind and the quality of response that we get. The second thing that I would like to underline is, after they have selected based on various parameters, they will then nominate one of the railway units, either a division out of the 68 divisions that we have all over India, or some zonal railways or some factories, to support the process. So Indian Railways will help you in taking it forward in all possible ways. That is the second major departure from the conventional model, so to say. And the third thing is that the IPR, the intellectual property rights, will remain with the proposer, with the small scale or startup, as you may like to call yourself. So the IPR will not get transferred, although Indian Railways will support you in development of a product or a technology, but the IPR will remain with the developer in all its forms. And should you succeed, the scale-up process will also be supported. The only thing is that the framework is available on the website that I'm sure you already know, innovations.indianrailways.gov.in. And I request that you must go through that portal, that website, in all its details, because that is important. The process is highly centralized with a view to make it very transparent and very efficient. And we are all trying to explain the problems. So the Railway Board has collected a large number of problems from all the organizations, and then they have selected first set of 11 problems, which we will make an effort today to explain to the best of our ability. I have, as Mr. Kiran has already explained to you, all the principal head of the departments with me, who are the ultimate subject experts, as well as this, as far as the Southwestern Railway is concerned. So we will try to give you the entire spectrum of the problem definition or description, as you may like to call it. And to begin with, I will request my senior colleague, Mr. Milind Devaskar, to share with you the major features of the new innovation policy of the Indian Railways. Once again, I am very happy to be with you, and we will be available, our entire team will be available to take this forward. Thank you very much. Over to Milind. Take forward. Thank you very much. Over to Milind.
Good morning, Mr. Kiran and the Diametrics team. This is the innovation policy. So this innovation policy is an initiative from Indian Railways to create an ecosystem for the startups to encourage innovation, and we wish with the support of these startups.
Yeah, just give a minute as we get the technical issues sorted.
This innovation policy is an initiative from Indian Railways, which through which we intend to leverage the technologies which has next generation technologies like IoT, big data analytics, cloud computing, drones, MEMS, composites, shape memory alloys, and now we are witnessing in our country a good startup culture. And through this, Indian Railways is looking towards a low-cost, user-friendly, reliable products and solutions for use on Indian Railways network. Normally, whenever some development takes place, there are concerns of the entrepreneurs. The concerns relate to capital inadequacy, And the second is delays in approval. And third is intellectual property and future orders. This policy caters to all these three aspects. First of all, the capital inadequacy is taken care of by milestone-based matching contribution from Indian Railways, subject to maximum of 1.5 crore. At each stage, the payment is limited to 25 lakhs. Regarding delays, the process, as you must have visited the Indian Innovation Portal, it is absolutely online, timetable, with clear decision process. Third concern is regarding intellectual property. The intellectual property remains with the innovator, and the advantage is that after the LOA is issued by Indian Railways and the proof of concept is proved, then the scaling up decision is taken within 15 days. And after the scaling up, and if required, there are some extended trials, then that extended trials are also to be completed within 12 months. And once the railway gives approval for the regular use, then it takes care of the future orders also to the entrepreneur. There are some government purpose rights also available, and in case these rights are exercised, then there is a clause on royalty of up to 2% of the supply cost per manufactured unit when the railways decide to get it manufactured through some other agency. So I will say that in brief, that as soon as the problem definition statements are uploaded on the Indian Innovation Portal by Indian Railways, then within 30 days, the proposals are to be submitted by all the entrepreneurs, and within 15 days, a communication will be received if your proposal has been approved. After the proposal has been approved, then the startup companies will be called for detailed presentation on techno-commercial aspects. And after the presentation is given and a detailed proposal is received, then within 15 days, Railway Board decides to issue letter of acceptance to the company. And once the letter of acceptance is issued, a division is nominated. Then a committee is also nominated in the division, and within 3 months, all the proof of concept and trial process will be completed, and Railway will be actively supporting the startup company in all respect. So we can expect that within a very limited time of, I will say that 3 to 4 months, in a time-bound fashion, if proof of concept is proved, then the scaling up and regular use clearance will enable opportunity to the innovator to a big extent, and all the concerns are addressed through the policy. Thank you.
Good morning, all. So now we'll start with the problem statements. And before we start, first slide. First slide. Okay, pehle isi yeah. We'll just clear few of the issues. This presentation is made with a view of elaborating the 11 problem areas and sharing the existing practice, what problems we are facing. And however, innovators are free to develop their own solution and should not be limited by any views expressed in the presentation or during the discussion. Interactive sessions for each of the problem statement have already been held through video conferencing by Railway Board. So I hope you all would have gone through that. And that website is a very dynamic one. That problem statement, they will be further enhancing through some detailed presentations or some documents. So you keep visiting the website at the innovation portal of Indian Railways for further developments. And for any further suggestions and informations, you can send your query to innovation@rb.railnet.gov.in. There is one contact person also named who can be contacted through mail or by phone for any further issues. So I will start the presentation now. Yeah. I would like to invite our Principal Chief Engineer, Shri SPS Gupta, for the engineering aspect. There are 5 problem areas related to civil engineering in our Indian Railways. So I welcome Shri SPS Gupta. Sir, आप इस पे आ जाइए. I'll do the presentation.
Good morning, all. I am SPS Gupta. I am Principal Chief Engineer on Southwestern Railway. We have identified out of those 11, 5 from civil engineering portion. The most important out of all the 5 is how in real-time basis we can monitor the rail stresses. As is known, due to movement of the rolling stock on the track, this is subjected to various types of stresses, which is you can say process the, and why these are so important to measure on real-time basis. Whenever there is a movement on the track, then there will be tensile stresses, there will be compressive stresses, and more so the other structures such as bridges, they are also subjected to excessive stresses. For bridges, we will be dealing separately in the other presentation. Whenever tensile stresses exceed the ultimate tensile strength of the rail, then it is liable to break. And due to that discontinuity, there are chances of any mishap in terms of derailment and other things. Secondly, if the compressive stresses then these exceed, then the rail or the track is liable to buckle, that it becomes sort of serpentine. So the various types of stresses which are faced by the track are vertical loads, that is due to live loads, or maybe effect, due to speed effect, dynamic augment, impact stresses, lateral forces due to movement of live load, eccentricity in the load due to track misalignment, or longitudinal forces because of tractive efforts or braking forces. Then thermal forces, which are always in longitudinal direction. Then contact stresses on the wheel due to wheel and rail contact. Then surface defects of rails or wheels, so flat tires, wheel burns, or maybe irregularity in the top surface of the rail. Then residual stresses in the rail when this is being rolled in the plant. Then there are certain issues that in what way we are resisting these stresses. One is we are fastening the rail with the help of certain elastic rail clips or the fittings, which are exerting a sort of load on the rail foot that is called as toe load. Then in the same way, for taking care of the thermal stresses, we provide a continuously welded rail so that the thermal stresses are remaining within the limits, and only the end portion of the rails will be subject to movement. Then due to temperature variation also, and the forces or the stresses are occurring. Then track defects and rolling stock, some defects may be there. Then quality of rail welding. We weld the rails there also. The quality of rail welding, that also matters for the excessive forces or at that location. Then due to trespassing also many times the track gets disturbed and the stresses are likely to create unusual circumstances. So right now we are looking forward that in what way the rail stresses can be measured automatically by providing some kind of arrangement so that it gives a pre-warning before any unusual happens or any failure takes place. Especially in real-time basis, if we get a self-actuated warning system, then we may keep the train speeds of the trains in at a lower scale, so that unusual may not take place. So that is one part of the out of this 11. That is one problem. Other is track inspections. We carry out next. We carry out track inspection in many ways. One is manually, that is foot by foot. Other is we move by some push trolley or a motor trolley. You, most of you or a few of you at least must have seen that there is a motor trolley or a push trolley through on which sitting the inspectors or the officers, and then they see the actual condition of the track as well as the other structures and so many other factors while moving on the track. Then we also inspect by while on the engine or while sitting in the last coach or the last vehicle. Then there are certain track recording cars also have been are enforced, which measure the track irregularities and other things. And one more arrangement of measurement of oscillations, accelerations are measured through oscillation monitoring system or OMS. Then these are various things what we see while moving through a push trolley or the motor trolley, what we see. Then this is done with the help of lightweight four-wheel trolley. The photographs are visible here. One can see. Then foot inspection, that is moving foot by foot on the track. It is done at various levels. At the lowest level, that is our key man. He moves daily on the track on foot. Then our JEs, that is, and then other senior supervisors are AN level or senior divisional engineer level, that is our at senior level, and they move on the foot as to see the condition of the track. Next. Then what do we see? That these have been detailed here. That is irregularities in the track, details of missing fittings, then greasing, then turnouts. You might be knowing what is turnout. Turnouts are basically to move from one track to the other track, and there is arrangement. Then switch expansion joints, it takes care of the movement in the rails due to temperature variation. Then the glue joints, these are used to provide insulation in the rails. Then cracked and damaged sleepers, if these are damaged, these are also seen. Deficiency of ballast. Then other things, other structures also are seen. Then condition of the track, that is track drainage, tunnels, cuttings, formation, toe load, and a movement in the LWR if there is an unusual movement in the rails. Then inspection of various gangs, that is what is going on the track while we are inspecting. So like how our people are working there, whether on the level crossing the person is alert, then a condition of the in the yards, then hot and during hot weather, during cold weather, then we do patrolling. During monsoon also do we patrolling, so that we can on real-time basis we can get the pre-warning that unusual is happening, and we can then stop the movement of the trains, and accordingly we can avoid or eliminate the chances of derailment or any unusual. Then track machines, while for attending the track, because now track structure is very heavy these days, so it cannot be handled manually, and accordingly track machines are deployed for attending the track, and so that whenever we go for inspection, we also see the how track machines are working and whether these are working properly or not. Then in the same way, ultrasonic flaw detection machines are also working for checking the condition of the rails and as well as the welds, because we have to weld the rails. Rails are these days are used on an 260-meter long rails are rolled in the factories, and these are then brought to the section. Then there is another way of checking, doing the inspection is footplate. What we call as footplate is when we are on the engine, and then we keep on seeing all around and the condition of the track. There, what we see is how the track, how is the running quality of the track. And then during night also we check alertness of the gateman, the station staff, the patrolmen, and watchmen, and observations of how whether the loco pilots are observing the signals, whether they are seeing the speed limits properly or not. Then other things also, including riding quality. Then track recording cars. These are mechanized instrumentation system of inspection. These are controlled by our RDSO Lucknow, and it is done for checking, doing inspection and monitoring of track quality. It is basically to see how the track parameters, such as whether these are unevenness, alignment, or whether it's properly aligned or not. The gauge, we have to fix up the gauge 1676. These days, the nominal gauge has been kept at 1673 millimeters. Whether this is properly, this is within the limits or not. The cross levels, whether the accordingly, how much twist is existing in the track is also seen, and it is recorded. And accordingly, it gives us results. And in order to see whether how the maintenance should be done, it is then categorized in 3 ways. That is whether the maintenance is urgently required, whether the maintenance should be done on need base, and whether it can be done in a planned way, and it can be deferred for some time. Then fifth is oscillation monitoring system. And this is a microprocessor based system to record oscillations, vertical oscillations as well lateral vertical as well as lateral accelerations. It depends upon the speed of the vehicle also, and it gives a sort of ride index quality. And it is GPS based, so it gives on in a proper way whether at what location, what kind of acceleration or lateral acceleration peaks we are getting. Then our suggestions are that whether any device can be fitted on a push trolley or motor trolley, so that it can give us the track parameters then and there only, instead of waiting for the track recording car or the OMS to be run, because these are run only periodically, whereas the trolley inspection is done almost on every 15 days by our supervisors. So if any device can be fitted on the trolley, then it can give us the value of the track parameters, whether these are within limits or not. Then more so, one more suggestion is whether any camera can be mounted on the trolley, on the motor trolley or push trolley or the locomotive for recording the and along with the geotagging, so that we can something is there. Because with the help of camera, we can get a video, and it can show other situations. That is whether how's the SAS, whether there is some encroachment taking place, or whether there is trespassing on any other obstruction, and condition of the land boundary pillars and other things also can be recorded, so that we really don't need to go to the site to check whether these are existing or not, or whether these are missing or not. So these are similarly, some camera can be mounted on the underframe of the loco or any coach, so that we can have a real-time assessment of the track condition on daily basis, and these can be auto processed, and action plan for track maintenance can be done. Then in the same way, lidar technology also can be used for it, and some lidar camera can be mounted on the trolley or the loco, and to collect the data. Then with the help of this mechanized inspection and generation of accession report, we can really have a real-time as well as pre-warning available to us in order to get attention done to the track. Then third problem is of inspection and maintenance of bridges. Right now, we do inspection manually of the bridges, or for the bridges where there is perennial water, in that case, we do underwater inspections also using divers as well as camera, and 3D mapping is also done. And on many cases for the river bed also, we use ultrasound system so that we know and what is the depth of the water as well as in what way it is flowing, so that erosion, whether erosion is taking place in the foundation portion or not. Then what we see in the bridge inspection is the structural integrity of the foundation, substructure, bed blocks, bearings, and girders, and also see how whether any cracks are taking place, so that accordingly we can analyze whether this is subjected to any excessive stresses, excessive forces. In the underwater inspection, we do 3D mapping of the riverbed as well as the substructure which is below the water level and which cannot be seen manually in normal course, and to see whether the condition of the concrete or the structure otherwise is in good condition or not. Then sometimes we do use remote sensing, but it is not much in use at this right at this juncture on Indian Railways. Next. एक slide पे, one slide. हाँ, नहीं इससे पहले purpose. Yeah, हाँ ये बात. So we really look forward that any mechanized inspection arrangement or device can be fitted so that it can auto measures the stresses or fatigue, etc., to give pre-warning if the bridge is likely to fail or not. And if it is self-actuated, then definitely we can assess whether that in what way the trains are to be run on this system, whether any speed is to be slowed down, I mean the train is to be slowed down, or the train is to the running of the train is to be stopped, depending upon the condition, depending upon the warning. Next. Fourth item is track cleaning. We are facing a real big challenge for dealing with cleaning of the track, because a lot many I think everybody must have seen who has gone in the station yards on the stations, that a lot of garbage is being thrown by the passengers and or otherwise. Next, please. In the yards, food wastages are thrown, plastic and food packaging material is thrown, unused items are unused or used items or whatever garbage people carry and they want to throw. It is very easy to throw on the track. Then it causes the blockage of drains, and this is unhygienic, as well as this is detrimental to the track also. In midsection, vegetation growth is there. Then again, throwing of used or unused items by the passengers, and throwing of plastic items and other garbage material. The present practice is manually it is done, and the yard drains are also cleaned manually. In midsection, again, vegetation is to be removed manually, but sometimes we had been using weedy sizers also, so that the weeds are killed, and then it is easier to take them away. Wastages are picked by staff manually. Again, drains are picked manually. This is something not only unhygienic, but it is inhuman. So what we want is mechanized cleaning without minimum disturbance to the train operation suitable to Indian conditions. Earlier, we had been doing either by off-track cleaning machines or on-track cleaning machines. So these are photographs which we had used earlier, practiced and tried earlier. The problems are in on-track. It is basically it is using the vacuum system, vacuum cleaning system. The normal vacuum cleaner sucks away the wastage of the garbage. And it is on the same way, it is very, very powerful. But the only problem with this is it takes away the ballast also from the track, because it is very powerful. So, and more so, it requires traffic block. We have to stop the trains while this machine is working or this vacuum cleaner is working. Then we cannot allow any trains to move. So this is again very costly. So far as our line capacity is concerned, it gets limited. Then on the off-track vacuum cleaners, the operation is very easy, no traffic block is required. But the problem is storage capacity is much less, output is much less, and again it requires very huge manpower to move for movement. Then fifth item, what I would like to present is the detection of rail well failure. This is really a pain in neck in all railway civil engineers, because any time any fracture can take place, whether it is rail or whether it is well failure. This may occur in either a station yard or midsection. Right now, we are detecting it either our keyman who moves or the patrolman who moves on the track on daily basis, and at that time he detects it. So, it comes to notice, then he informs, and accordingly trains are stopped, and this is protected. The track is protected. Or the PB engineers or the supervisors who are moving for their routine inspections. During that period, if it is noticed, then again protection is to be done. Many times the loco pilot, the guard, they feel jerk. If suppose the fracture has taken place and the train is moving, at that time they feel a jerk. Then they give a jerk message, and accordingly he gives a message to the station's staff, and then the engineering staff, they move to the site, then they protect the track. Then sometimes outsiders also report. If it comes to their notice, then they also report that some fracture or some crack is being seen by them. And then again, we take precautions to secure it. But many times when the key man has passed and after that the failure takes place, it is not noticed. In the same way, the frequency of the PB engineers is also not daily. It is on 15 days basis. So again, it is likely that they may miss. Sometimes loco pilots or guard also may not notice, or may go unreported if the jerk is not adequate enough to come in their notice, and if it becomes a normal kind of jerk. So in the station yards, of course, due to track circuit available, the track circuit fails, and accordingly it comes to the notice of the station master, and then protection of the track is ensured. So right now the problem is there is a time gap between actual failure and detection of these failures, and this is where our problem is, because it will endanger the safety. Though we Indian Railways and civil engineers specifically, they are trying their hard that failures are brought to the nil, but normally it is not possible, because I already spoken about the stresses in the track. There are so many types of stresses, and more so, especially when the stress level goes much beyond the acceptable level due to impact stresses, maybe because of flat tire, maybe because of irregularity in the track, maybe some other reasons. So that in that case and at that stage, it becomes so very difficult to control the failures of the rails or the belt. So we really need to detect these rail belt failures, especially in the block sections, because in the station yards, we due to the track circuit failure, it comes to the notice of the station master. But in the block section, there is no such mechanism where we can really detect them on real-time basis, and therefore we really need some kind of arrangement or some kind of a device which can be fitted without disturbing the rail or the cutting the rail. If it can be done on outside or can be fitted outside without making any hole or cut in the rail, then it is a welcome innovation, and they've definitely be taken immediately by the Indian Railways. Thank you.
Gupta ji, would you like to take one or two questions?
Any questions?
Yeah. Participant, anybody would like to have questions? There's one question. Does trolleys have power source for camera, or we need to provide inverter, and is there a space for that?
Yes, it can be. It is possible.
Okay. Trolley has a power supply for the camera.
It has to be a battery supply. It does not have power supply as such, but battery can be kept. No problem about that.
Okay. Okay. And space is there for the battery to install that.
Space is. That can be done. That is possible, because that is not a much difficult a job.
Okay. Got any questions, participants? Anybody like to ask Gupta ji directly? Where are well located on the tracks? I'm just looking at the charts and then asking these questions.
नहीं देखिए ऐसा है वेल्ड का प्रॉब्लम ये है कि वेल्ड की जो नॉर्मल अभी जो हम लगा रहे हैं 260 मीटर का एक रेल पैनल होता है। तो अगर हम ब्लॉक सेक्शन में लगाते हैं तो आप यूं मानकर चलिए 1 किलोमीटर में 8 वेल्ड हो जाते हैं। बट स्टेशन यार्ड्स में कुछ ज्यादा होते हैं बिकॉज वहां पर छोटी रेल्स का इस्तेमाल करना पड़ता है, स्पेशली जहां पर टर्नआउट्स होते हैं वहां पर या अदरवाइज। और जो हमारी लूप लाइंस होती हैं वहां पर हम 3 रेल पैनल यानी आप 39 मीटर्स या 36 मीटर्स लॉन्ग पर होता है उस पर हम वेल्डिंग करते रहते हैं। अगर सिंगल रेल पैनल भी हमें सिंगल रेल भी इस्तेमाल करनी पड़ती है जो कि 13 मीटर लंबी होती है, then there the number of welds get increased. Right now, for example, if I say so, on SWR, there are more than 1 lakh welds are there.
Okay, so we'll not able to take all the questions now, and we'll provide an email ID, and also these questions are passed on to the.
My number is available. My number is available with Mr. Pandey, and I can be contacted directly also.
Okay. Okay.
Absolutely no problem.
Thank
Or
you.
else I can give my number if people are interested. Then I can tell my number right now also.
Okay, can you please, Gupta ji,
I'll say 97
97
3166
3166
5200.
5200.
Yeah.
Okay.
Yes,
I
yes,
put it in the chat too. Chirag, do you have a question? One question, live question. Chirag, raise your hand.
Yes,
Is
so
there a
we'll
question?
just unmute Chirag. Just give a second and we will ask him to. Yeah, Chirag, you can ask a question.
Okay, first of all, thank you very much. This is Chirag here from Plutoman. So just wanted to ask one question regarding, have Railway thought about anything specifically in terms of the augmented reality solutions based on the smart glasses where it can not detect, but it can actually visualize the thing, and probably the person who is sitting across probably in the expert probably sitting somewhere not in the same platform, or probably he's sitting somewhere in Delhi or Mangalore and he wanted to see the overall platform, right, where the tracks or anything is being inspected. So have we thought about it? Because yeah, we are doing in the same space, and I guess it is solving so many people problems. Yeah. Augmented reality with the help of smart glasses, sir. So जैसे आपने glass पहना है ना sir, the same similar glasses can be fit. It will have the camera, it will have the microphone. You can directly call from that. You can fill up the checklist, whatever you are right now maintaining on the piece of pen and paper. We can digitalize all this. So have we thought about that kind of solutions into the mind, which will increase the productivity, which will decrease the error rate, and probably it will give you hands-free operations? Yes.
We have not used augmented reality so far.
Okay. ठीक है sir. So I guess
I think detailing further can be done
okay.
For any kind of idea. That is why I'm giving my number so that we can discuss it directly, and because sometimes your idea can be further discussed, some other offshoots can be taken out of it.
Sure.
So we can discuss it subsequently also, no problem.
Done, sir. I have your number. I'll give you a call probably. Yeah. Thank you very much. Thanks for your time, sir. Thank you. Thank you all.
Thank you.
Prem Prasad, do you have a question? Gupta ji, there's one last question.
Yes.
Move on.
We'll
Prem,
just
do you have a question to ask?
yeah, Prem, you can speak now.
Sorry. Yeah. Hello. I just want to have one question, a couple of questions. Would you be able to provide data on the jerks? You're talking about the jerk being noticed by the drivers, and then he sends a message manually to the to your control. Can you hear me at all? Am I audible?
Yes, you are.
We can hear you.
Okay. Can we have the data on the jerk?
नहीं reporting तो वो regularly करते हैं. Or say so far as oscillation data are concerned,
Yeah.
we are running that oscillation measurement device very regularly. And based on, and these are, on real-time basis, these are conveyed to the engineering staff and its supervisors, and they attend it. So that is not a problem at all. No, driver, जो reporting by drivers is quite frequently,
Okay.
wherever it is there. But these days, the track structure is so good that now it has decreased quite a lot. But whenever there is some irregularity or some jerk message, almost on, I should not say that on daily basis, we are receiving any kind of this kind of reporting by the drivers.
Okay.
So in a month, maybe 3, 4, 5, not more than that.
Okay. So would you consider that that's a serious problem still?
Not getting. Can you please repeat?
Yeah. Would you consider that that's a serious problem, and do you have a recorded data on that, like something that can be put into your, say, a machine learning algorithm for predictive inferences?
Yes, whenever there is a message which comes from the driver for any jerk message or any oscillate data, then immediate attention is given. Immediately, the supervisor runs to the site, he checks it, and then reports back. And a feedback system is also available to give to the driver whether something unusual has been found or not.
Okay, sir. So just one more question. Would Indian Railways also be interested in on-site repair solutions, say, for example, with lasers?
Yeah, along the track. Yes, we the mobile system is welcome, because online it becomes it is not clear, because Indian railway track is so much that is very difficult and very costly also to fix up online. So rather, it's a mobile system is better, so that it gives so that we can run it and accordingly we can record it. And at the moment this recording system reaches to the next station, and if it is recording something unusual, then it can immediately be attended also.
Okay, all right. Thank you, sir. Thanks a lot.
Okay. So Duttaji, thank you very much. We need to move on. Ravi, Sanjay, Shubhank, sorry, you can have these questions directly asked later, but we need to move on. Thanks, Guptaji.
Thank you so much. Thank you.
Good afternoon, all. My name is Subba Rao. I'm a Principal Chief Mechanical Engineer. I actually look after the rolling stock, wagons and coaches, and their operations and maintenance. 2 problem statements have been identified by the board. The first one is elastomeric pads for heavy haul freight wagons. Our wagon has got 8 wheels. So the 2 wheels on each side are mounted on a frame. This unit is known as a bogie. So a rolling stock, either a wagon or a coach, has got 2 bogies and 1 body. Kastner bogie, what you see here, Kastner bogie is the standard bogie which we are using in the Indian Railways for all our wagon stock, freight stock. There are many versions of that, but basically there's a common design. The bogies have got 2-level suspensions. One is a primary suspension, one is a secondary suspension. In coaching stock, if you have seen trains, you'll see springs on 2-level springs are available. That is both the primary stock and primary suspension and secondary suspension. They got springs. But whereas in a Kastner bogie, earlier the first design, we were not having the primary suspension. We found that a lot of damages to the bogie was happening and coach was happening, wagon was happening. To reduce it, we introduced a rubber pad, an elastomeric pad, in the primary suspension level. You go to that bogie. Yeah. This is what we say a bogie. So this is the elastomeric pad, and these springs are the secondary suspension springs, And these are the primary level. There's only a damper. There's a rubber damper. What has happened of late is that because of improvement in speeds and our turnaround of the wagons, the number of kilometers earned by the wagons every day has gone up. So because of which the rubber which is available here is has to dissipate too much of a lot of energy on a single particular day, due to which aging of the rubbers is happening. We expect the life of these elastomeric pads to be 6 years in a closed wagon and 4.5 years in an open wagon. Open wagon is where you load the consignment from the top, iron ore, coal and things like that, and bagged consignments are loaded in the closed wagon. But off late we find online failures are quite high, which is resulting in detaching them from running trains and attending them in the sick lines. This is how the weight transfer in a wagon takes place. Here is the EM pad, and the unsprung mass is just the adapter in the wheels below the EM pad. This is how the EM pad looks right now. This these are the metal plate, and the rubber is available both top and below and above the rubber plate, and they are bonded together. And this takes the load. There are 8 of these in each wagon, 2 on each axle. We are having a original specification is WD20. Right now we are having this specification. This specification is slightly modified to a second revision. This is yet to be, the first original version is being at the moment produced. What is known as the design B has been developed, which is also being, some of the vendors have actually approached the RDSO and they are giving their products. But what we are looking at is not the WT20. One more specification known as the premier specification, known as WT37, which on the right side can be seen. This has been developed by the RDSO. Here also a lot of, the envelope also has been changed in this, and the vendor is free to develop his own envelope. He did not stick to the envelope what I have shown you earlier. The amount of rubber and the quality of rubber can be changed. The specification, the present specification, some vendors are coming forward and they're giving their product for testing and things like that. But what we are looking through this startup forum is don't stick to the specification. What we want is something equal or something better than this. And the damping material need not be rubber. It can be any synthetic item also. And even the profile also can be changed. At the moment, our wagons have got an axle load of 22 tons, 22.5 tons. But the future wagons are going to have 25 tons wagon load, axle load. So about 100 tons will be the total weight of a wagon with the payload. WD30, what you have seen specification, is basically addressing a 25-ton axle load wagon. The idea of involving startups here is that you can come up with a better specification and a better product. This will be tested at the moment. The specification specifies 1 million cycles of fatigue testing. The fatigue testing can be done either at RDSO or at any NABL accredited laboratories, or at the firm premises also, which will be of course supervised by the RDSO. So these are the different kind of loads and loads which come onto the EM pad. I'll just show you the failures. Both the failures. This is how the failures look now at the moment. You can see that the plates are getting sheared off, they get dislocated, and they get bent. Generally, we expect 3.5 years as the warranty period for these EM pads. That's what the specification specifies. And we expect a life of 1 period cycle. That is one periodic overhauling cycle, where the wagon goes to the workshop. So we don't want to change it between workshop to workshop visit. So the wagons visit, depending on the type of wagon, they visit to the workshop once in 6 years or once in 4.5 years. So any changes or any replacement of this component in between these workshop visits is basically time consuming and loss of money for us, running capacity for us. So this is in brief the elastomeric pad issue which we have identified. This is of course the consumption level. You can see that consumption has gone up of late. Next problem is complete design of a wagon itself. There is one product, salt, which is loaded in mostly in Gujarat area. The salt is loaded either in loose salt or in bagged salt, bagged consignments. At the moment, these are being loaded in our standard box and wagons. But salt being highly corrosive, it damages the body of the wagon. We are not looking at the change in design of braking system or the wheels or the bogie portion. What we are looking at is a new body. The body could be, of a different material altogether. The body could be, the present wagon could be modified by having some kind of a layering, some kind of a covering, so that the wagon life is enhanced and the wagons don't get corroded. At the moment, there are no, of course, this is, at the moment, our wagons have got IRSM M44 cotton steel, which is a corrosion resistant steel, which has got a little bit of copper in it. But then even these are not suitable for loading salt. You go to the prototypes. Some prototypes were developed by RDSO and some industries. Pesco is a company which has developed these two wagons. There are only 2 prototypes have been developed, not yet deployed into service. At the moment, there is one company called Tata Steel, which is actually working on, this is a solution being developed by Tata Steel, where FRP lining is being suggested inside the body. So this prototype is not yet come out, and it may take some time. The idea is if any startup wants to come up with some kind of a solution, keeping in mind the overall dimensions of the wagon are not changed, but idea is to reduce corrosion and reduce the weight of the wagon so that more payload can be carried. Yeah, these are the functional requirements. I'll go back. These are the functional requirements of the wagon, what we are expecting. Yeah, that's the brief of the 2 statements, problem statements from my side. Any questions which I'm able to answer right now, I'll do it. If not, I can be contacted.
We can take 1 or 2 questions if
Yeah.
there are some questions. Okay, any questions from anyone?
I'll just tell my number also can be noted down.
Okay.
Yeah, my name is Subba Rao.
Yeah.
My number is 97 31
97
31
31
66
Okay.
54 00.
Okay. Done.
We have a question from Abhishek.
Yes, it talks about water resistance. Yes, exactly. That's also required because salt is being carried. We don't expect salt to get wet. So water resistance is important.
Okay, if there are any questions, Subra, we can take it at the end too.
Sure. Okay.
Okay. Thank you.
Thank you.
Morning. Am I audible to all?
Yes.
Kiran,
Yes.
if you can just give me a feedback.
Yes, we can hear you well. Please go ahead.
So this is basically what we're trying to get done. Headway improvement system for suburban sections interoperable with Indian Railways national ATP system. So this is railway speak for saying that suppose I want to enhance the number of suburban trains running in Mumbai with the existing infrastructure. Is there a possibility of getting it done, and how do I go about doing it? So that fundamentally is what we are looking for. So we'll come down to some of the traditional methods in which we define headway and how we've improved it over time. Headway is essentially the gap between two trains. So if I can reduce the gap safely, then I can run more number of trains, and obviously that enhances the capacity. I mean, that is the fundamental with regard to the headway. So lesser the headway, higher the section capacity. Section capacity is basically in a particular section, let's say between two junction stations, how many trains can I run at one go? The next is section is divided. Normally in railway jargon, section is between two junction stations. These junction stations are divided into blocks, multiple block stations, block sections. A block section is basically the track available between two stations. So multiple block sections constitute a section. And each block, essentially what is being done is the trains are being spatially separated, and each block section becomes one particular area in which there can be only one train. So next. We have a system of working called the absolute block. So the space between two stations can be occupied only by one train. It is ensured through the signaling system. Now, in case of, so essentially what you're seeing here on your screens is there's a double line, there's a single line section. Essentially between two block stations, you have a single line. A lot of work is being done to double track all across the country. And in fact, now even up to quadrupling them. The second is between a double line section where you have a traditional, the direction of traffic is unidirectional. In case of single line, it's bidirectional. In case of double line, there's a traditional orthodox method of working it. We call it an orthodox double line working. So this is basically the one method adopted for operation of trains across the Indian Railways. Next. Now, idea was to enhance the capacity. Can we improve it? So an intermediate stage called an intermediate block signal is being provided. So I can have two trains in one particular block section. So this is basically a step up from the traditional absolute block. So I have an intermediate block. So I can enhance the capacity, double it. Now the latest, which is done extensively in suburban sections world over, is what is called the automatic signaling. The automatic comes up because the signals here need not be operated manually. The area portion of track ahead of a signal monitors the availability and occupancy of that particular track, portion of track, and the signal accordingly is given a proceed or a stop, depending on the section being occupied or otherwise. So now this fundamentally is the way we've been working so far. Now the premise so far has been, and extensively on Indian Railways, we assume that the driver, and fortunately the drivers do comply with the signal aspects. Now the question becomes, what if a driver mistakes the aspect of a signal or misses a signal? So now this is one area where we are looking to address. So we have a local development, which is called the TCAS. I think a lot of recent press on this, called the Train Collision Avoidance System, or KAVACH. Now here the idea is that in case the driver does not respond to aspect of a signal, or his speed is not commensurate to what it should be, then the system has the intelligence to analyze it and start application of brake if required. So essentially, this is a fairly complex problem where the system has to understand the aspect of the signal on one side. Second, look at the braking characteristics of the train, meaning to say that one possible fact is that the driver takes 1 kilometer. When he applies a brake, the train typically takes 1 kilometer to go and stop. So it becomes very critical that he applies the brake at the right place. So in this particular case, the system is monitoring the response of the driver on real time, analyzing it versus the speed it should be, and starts to apply the brake as required to enforce that the stopping of the train at the in a safe distance. Now, if you notice this, the train collision avoidance system, I've just summarized some of the aspects which it's providing right now. It displays the signal aspect ahead in the cab. So the driver need not any longer look at the signal physically. The aspect of the signal which is going to come up is repeated in the train. It monitors the signal speed and braking action of the loco pilot. It prevents overspeeding, prevents signal passing at danger, which is a strict no. And they are treated as accidents in railways. So a lot of deterrent action is taken against the driver in case he just passes a signal, even when there is no repercussion otherwise. So signal passed at danger is viewed very seriously in the railway context. It controls the speed as per the speed restrictions. Typically between two stations, because of the condition of the track, at times it may be essential to impose certain speed regulations. That is, whatever is the unrestricted speed, we regulate the speed at certain spots. So this system also caters for that. And that information is available. The speed profile of the section is also available within the loco for it to brake. Straight away, it prevents collisions, because once there is a train coming in the opposite direction, then both of them are designed in such a manner that they respond promptly. Then the other byproduct is it also whistles at a gate. One of the requirements at a level crossing gate is that driver is expected to whistle. Now that process can be automated and programmed. So depending on the location of the train, when a LC gate is approached, it can whistle. So essentially, if you notice, the entire track profile is fed onto it. The locations of the stations are fed, locations of the signals are fed, location of level crossings, any other incidental information which is of importance to the driver is all fed on real-time basis into the loco. Now, it also can be centrally monitored across the entire section where TCAS is being introduced. Right now, the intention of Indian Railways is that we are concentrating on two sections primarily, between Delhi, Mumbai and Delhi, Calcutta in the first phase. Then it will be extended across what we call the GQGD, that is the Golden Quadrilateral and the diagonals. And this is one part of it. Here, if you notice, the entire system of indicating to the driver is still dependent on the existence of what are called line side signals. The next generation, the next. Yeah. The next generation, which is essentially used in metros, it's a very popular technology which is widely adopted in metros, still to be introduced on the Indian Railways, is what we call this communication-based train control system. Here, the intention is that the train is directly communicating with what we call the radio block center. So essentially, the entire monitoring of this train is being done centrally, and the train interacts on real time with the radio block center. Essentially, it's a centralized signaling system, radio communication based, high resolution and real time train control information is passed on to the train. Now the concept is moved from spacing my train into different block sections. I ensure that the gap between the trains is consistent and is safe. So this particular aspect is a further development, and this is treated as the most optimum solution with regard to utilization of or having maximum section capacity. And maximum headway possible is maintaining the gap between these two trains, monitoring each monitors the other's movement on real-time basis and accordingly starts to brake or accelerate. Now, this is essentially done in metro stations, metro rail, where the composition of the rake is virtually uniform. While in the case of Indian Railways, the challenge is we run suburban trains, we run passenger trains, express trains, goods trains, all of them on the same track. While metro, it's essentially restricted to passenger trains. And the type of rakes, capacity of rakes, speed potential of them is all virtually identical. So much simpler system to adopt in metros and established system world over. So this basically the communication, go back. Yeah, the communication technology used is GSMR. It was a version of GSM developed specifically for railways called the GSMR. This is a European standards, and then you had Tetra, which is the Australian standard for communication on real-time basis in CBTCs, CBTC areas. The newer version is LTE. In fact, railways, we are trying to adopt LTE now, try to evolve an LTE for realizing this real-time communication with the driver and guards and station staff and the maintenance staff working along the railway track. Next. So I think what is expected from the system, this is a high resolution train location determination independent of track circuits. Continuous high capacity bidirectional train to wayside data communication. Train borne and wayside processors performing vital functions. Essentially, we have onboard computers which analyze everything in terms of the speed profile, the section profile, the driver's response, and any updated information which is important for the train to regulate its speed. Then we have the automatic train control, essentially, which starts to brake by itself. All these have to be compliant of a SIL4 standard. Basically, the safety integrity levels there's a certain standard which is determined world over. So SIL4 is the highest level of safety which is expected from a particular equipment. The SIL standing for safety integrity level. And the design life of this entire system is expected to be about 30 years. So by and large, I don't think from my experience that there is more deep tech. This is as deep tech can get. So this is basically what I had to say. I can take any questions. Or is it that it's too much to digest in a 4-minute presentation?
Very interesting, very challenging one. Okay. So, Rashika, there's two questions in the chat. Is TCAS already prototyped and running?
Oh, yes. In fact, it's been done in Secunderabad. There are basically 3 companies which are doing it. One, Kernex, HBL, and MEDA. And the Indian Railways is looking to expand capacities and install about 2,000 kilometers is planned in the next, I think, 3 years. And they want to spread it out everywhere because one thing which has to be appreciated is even today, the entire system of response is a driver responding to a signal. So there are going to be challenges in the future. So TCAS is the Indian evolution. There is an equivalent called ETCS, which is the European Train Control System, but India has developed its own version of it. So already trials have been done. They are going to be extended. The prototype developed. It's under acceptance. For this 2,000 kilometers, it's with this version of TCAS that is going to be implemented. There are further versions which have to be developed. Presently, it's called version 3.2. The next version is going to be 4.0. And beyond that, it's going to be compatible with LTE. So for that, LTE development is also occurring in parallel. So right now, it works on a UHF band. There are towers being provided all alongside the rail track, and the communication is available with the radio block center.
Okay. Rashika, we'll take one more question. How many RF transceivers are needed per kilometer of the track?
Okay, now this question is, it depends on what is being planned. Meaning to say that, are you planning today we are looking at UHF. I think UHF, the spacing is about 4 to 5 kilometers. Typically, the block stations are about on the average 12 kilometers apart. So we'll have 2-3 locations in between so that the communication is available on virtually a real-time basis. or the information update can occur at these 3-4 locations. Incidentally, I thought I saw another question in the chat. Railway has been allotted frequencies. So that's the reason why we are working on developing LTE, because GSMR is an outdated technology. So now we are looking at developing LTE specifically for railways, and the frequency bands are available. I think there are 10 spot frequencies allotted to Indian Railways, basically for train control purposes. It is not to be used for passenger amenities or facilities to passengers.
Okay, there are 2 more questions.
Yeah, please.
As more sensors are added, do you expect those to use the same LTE spectrum used for your operator communications?
Sorry, can you just go back on the question?
As more sensors are added, do you expect those to use the same LTE spectrum used for your operator communications?
Yes. Basically, what's happening is we also have an optical fiber laid all across the railway track, right? So it's fundamentally the mobile towers are used as last mile access. So you access them, it goes onto a backhaul, which is the OFC, and then goes through your switches and whatever is the arrangement with regard to the train control applications. So with this 10, in fact, there were 8 spot frequencies. We were insisting on 10 so that they can get repeated after the 10th spot. So in that sense, that is the best way of realizing spectrum efficiency on one side and ensuring the integrity of the communication. Because once we move into the realm of train control communication, you're looking at a safety application 1. So a lot of information, braking, safety is all going to be on this particular communication. So it has to be extremely reliable. So these things have been calculated, and there was a bit of a stalemate. We wanted 8 spots. It's been given as 10 now, if I recall right. So it's available. We have to start implementing.
So are there any LTE electronics specification need to meet, or is it an automotive grade?
There is an LTE spec which has been evolved by RDSO. In fact, I think Railway Board is working with CDOT for evolving the technology. Because in fact, the dilemma here is LTE is good enough for our applications, but LTE as a manufacturers have started discontinuing LTE production of LTE equipment. They're looking at 5G.
Okay. Okay, I think some of these remaining questions must be taken with you. Rajshekhar, can you share your contact details?
Yeah, absolutely. My number is 973166.
Can you please repeat just a second?
Yeah, 97.
Sorry, can you please repeat?
97.
Yeah.
3166.
3166.
5800.
Okay, Rajshekhar.
So it's been a unique experience, and it's a pleasure interacting with all of you. We are looking forward to extending whatever support we can and ensuring the success of this. There are a lot of areas of machine learning and automation which can be applied on Indian Railways. So I'm hoping a lot comes out of this initiative.
Yes, a lot of our startups will be interested in this space. You can really expect more interactions from them with you directly.
Right. Thank you.
Okay, so thank you very much. We are close to the time, another 4 minutes. If there are any questions, any specific to any speaker, we can have 1 or 2 questions, else we can conclude the session.
Sir, we'll have one short, quick last presentation regarding an electrical issue, sir. And GM will be visiting, sir, soon after for the concluding remarks, sir.
Okay.
Yep, we'll start, sir.
Good afternoon, everyone. I am Sanjay Kumar, Chief Technical Loco Engineer. The problem statement here is that development of online condition monitoring of the traction motors. So I just brief what is the traction motor. Maybe you may be knowing what is the traction motor. Just I will brief. And one locomotive, we have around 6 traction motor. The rating of the traction motor is 850 kilowatt. It's around 2000 volt and 1300 RPM around. So weight of the motor is 2.1 ton. So these are very, very heavy equipments and very important part of the locomotives. The problem for the traction motor, what we are facing, particularly in 3-phase locomotive, there are basically 3 types of failures occurs in the traction motor. One is the stator winding failures, which are very, very less actually. They are winding failures, electrical failures basically, the interturn float or short circuiting or overheating, but very less. This problem is very, very less. Second problem which occurs in the rotor bar. The rotor is having the typical induction motor type of rotor. They have the bars these are the copper bar basically. So sometimes cracks in the bar occurs, for which to detect those cracks we need to test, we need to take measurement in the locomotive shed through the LR value of the traction motor, which varies with the crack in the bar. So that is possible only when loco visit in the shed during the maintenance. So that is the one problem statement, which if it can be detected online monitoring through online monitoring. Third problem is which is very critical and which is very serious one, is the bearing failures of the motor. So we have 2 bearings. One is driving hand side, another is non-driving hand side. These are roller bearing. Once this bearing fails, the complete loco become immobile. So the axle seizes and loco cannot move on the main line, and the complete line blocks. So a special rescue has to be done for the locomotive. The wheel is to be lifted with the trolley, then only loco can move. So these are the problem which we are facing now. There are a lot of engineering done in this, but still we are getting the cases of the failures. So that is the main problem statement for online monitoring of the bearing actually. So bearing gives indication before failing finally actually, because it starts with the some starvation of grease pitting in the bearings. So it gives indications in the form of vibrations in the bearing and increase in the temperature. So these are 2 indications which before final failing of the bearing, which comes actually. So we have to capture, if we can capture those signals before bearing fails, so we can avoid major line block. The locomotive can taken to the loco shed for the maintenance, and line block can be avoided. So that is the major problem we are facing. So for this requirement are basically to capture these 2 signals. Maybe innovator may give other solutions also apart from these technical details or signals we get from the bearing before bearing finally fail. So it involves, the innovation will involve design of the sensors. We can capture the vibration and temperature of the bearing. Design I mean mechanical design also, to fit those sensors at the appropriate location where these signals give the accurate true reading, not the false reading. Because if they give the false reading, then our maintenance will increase. The false signals will lead to the non-reliable detection. So mechanical design has to be accurate, and then whatever data we get from this that data has to be sent to our maintenance centers. We have control room in the divisions. We have shed, home shed for the locomotive. So that data is to be sent to the home shed and control rooms. So that action can be taken by the control rooms and sheds to take out locomotive from the service. So for that, whatever whether 4G, 5G system, it depends innovator which type of the system wanted to give. So that not the issue. And so that's all which I wanted to say all about. I think everything is clear.
Thank you very much.
Thank you,
And
sir.
we don't have time for any questions. So what you do is we give the email ID, Ashish Pandey,
Yes, sir.
General Manager, Deputy General Manager. You can write an email to him and he will internally coordinate to pass on to the respective division and get it answered.
Yes, sir. So at the end, our general manager would like to give concluding remarks, sir.
Okay, so
I invite
Yeah.
general manager to please address the gathering, sir.
request General Manager to come and then give a concluding remarks.
Yeah, thank you very much to everyone who had the patience of staying till the end. I think it's a good number, 75. I think we peaked around 98 or 100, and that's a very good retention coefficient, if I may say so. I hope we have been useful, and of course we are available in case of any confusion or if you need any clarification, so to say, before you submit your proposals on the website. If there is a quick resolution, need for a quick resolution, we are available. We hope to take it forward. We hope this effort will bring some fruit in the form of at least some serious proposals. And thank you very much once again. Thank you.
Thank you very much, sir. It's been a really wonderful session. Thank you everyone at the South Western Railway. Sanjay ji, Milind ji, Rajshekhar, Neeraj, Subbarao, Sanjay Kumar, Shyam Singh. And also I have posted the email ID of Ashish Pandey, Deputy General Manager, General. If you have any questions, please write to him and he will internally coordinate with the officials. Once again, thank you very much, each one of you, to make your time and participate on Wednesday. Okay, and busy day, office day, working day. Thank you very much. So let's make use of this opportunity and work with railways to solve